For 91 years, scientists believed they understood the universe. They said it has 27% dark matter, 68% dark energy, and 5% ordinary matter. Every textbook taught this as proven fact, but what if they were wrong? NASA didn't hold a press conference. There were no big headlines worldwide. Instead, Nobel Prize winners quietly said the model might be broken. The James Webb Telescope saw something it wasn't supposed to see, galaxies that shouldn't exist yet. And suddenly the foundation started to crack. Imagine spending your whole career on a wrong theory. That's where cosmology stands right now. This video reveals what NASA-funded research now confirms, the evidence they cannot ignore, and the truth that could change everything. Let's go back to where it all began. In 1933, Fritz Zwicky studied the Coma cluster. He saw galaxies spinning too fast for their visible mass. By every physics law, they should have flown apart, but something invisible held them together. Zwicky called it dark matter. His calculations were off by a huge margin, but his core conclusion seemed correct. Most matter in the universe was invisible. His peers ridiculed him for decades. They called him eccentric, abrasive, and wrong. He coined the term spherical bastards for colleagues who attacked him from every angle. But by the 1970s, astronomer Vera Rubin confirmed his findings. Galaxies rotated in ways visible matter couldn't explain. Dark matter became accepted science. But was the interpretation accurate? By the 1990s, dark matter became the foundation of cosmology. The Lambda CDM model explained everything about the universe. It said 27% dark matter, 68% dark energy, and only 5% ordinary matter. Every simulation and calculation was built on this idea. The model explained why galaxies spin the way they do. It explained how light bends around invisible mass. It predicted the cosmic microwave background patterns we observe. Everything seemed to work perfectly. Dark matter was never detected directly. Scientists only assumed it existed because nothing else made sense. What if this assumption was incomplete? NASA bet billions of dollars on finding it. Decades of experiments searched underground, in space, and at particle accelerators. Fermi, NuSTAR, and Chandra searched for its signal. The Large Hadron Collider smashed particles together, hoping to create dark matter. Scientists looked for WIMPs and axions. These tiny particles might prove dark matter exists. Underground detectors waited in silence for a single dark matter collision. Year after year, they found nothing, not a single particle, not one confirmed signal. The Roman telescope launches in May 2027. It will create 3D dark matter maps across billions of light years, but will it reveal a flaw instead? NASA doesn't make announcements when paradigms crack. Journals do. In 2024, the first cracks appeared. Not from failed experiments, from observations that didn't match the math. These problems fall into three categories: expansion, formation, and gravity. The universe is expanding every second, but scientists found two different speeds. One method says 73 kilometers per second per megaparsec. The other says only 67 to 68 kilometers per second per megaparsec. Why don't they match? This isn't a small disagreement. It's a 9% difference that refuses to disappear. Every new measurement makes it worse, not better. The gap is now statistically undeniable. For years, they called it the Hubble tension. In December 2024, Nobel winner Adam Rees published shocking research. Hubble and James Webb confirmed the gap was real. It wasn't a measurement error at all. The tension became a full crisis. Rees said it clearly: funny dark energy or funny dark matter. Scientists acknowledged the math was wrong. A model can be wrong in parts without being entirely false. But what comes next? Then James Webb saw something even more disturbing: galaxies that should not exist yet. The James Webb Telescope launched in December 2021. It was built to see the oldest light in the universe. Scientists expected tiny, faint galaxies forming slowly, but what it found shocked everyone. Massive galaxies appeared just 300 million years after the Big Bang. According to Lambda CDM, this was completely impossible. Dark matter halos didn't have enough time to form them. How could these galaxies exist so early? Jade's GSZ 13.0 and JD's GSZ 14.0 were too bright and too big. Some showed organized spiral structures, others displayed supermassive black holes already billions of times heavier than our Sun. The universe was supposed to be an infant. Instead, it looked middle-aged. Even the best calculations couldn't explain them. The math simply didn't work anymore. This is the moment cosmology stopped adding patches and started questioning foundations. Scientists faced a hard choice. Either dark matter behaves completely differently than expected, or it isn't what we thought at all. Professor Catherine Fries proposed something shocking. Some early galaxies might not be galaxies at all. They could be supermassive dark stars. Imagine a star that doesn't burn hydrogen. Instead, dark matter particles crash and destroy each other. This releases energy and creates light. A star made of darkness itself. These objects could grow to 10 million times the mass of our Sun. They could shine brighter than entire galaxies while remaining invisible to normal telescopes. Scientists studied JD's GSZ 14.0 closely. They found a special helium-2 absorption line at 1,640 angstroms. This matches dark star predictions perfectly. Fries called it the first real evidence for dark stars. If true, dark matter isn't just sitting there. It's active, burning, and creating light. Dark matter might be scaffolding, or it might be a shadow cast by broken equations. Today, his models match observations better than the standard theory. One scientist betting everything on an idea the world rejected. Which theory will survive? NASA hasn't issued any formal retraction yet, but NASA-funded papers now openly question the assumptions behind dark matter. The evidence is spreading everywhere. This is not a small correction. The entire framework of cosmology is trembling. Admitting dark matter is wrong means billions were spent chasing assumptions. It means every galaxy mass measurement needs recalculation. It means distances across the universe might be different than we thought. Textbooks everywhere need updating now. We never fully understood 95% of the universe. The invisible universe may be very different than we thought, or it may not be invisible at all. If this model is wrong, every cosmic measurement you've ever seen is suspect. But science doesn't fail when models break. It advances, and we may be watching that moment now. The universe hasn't changed. Our understanding has. Subscribe if you want the truth science hides. Like this video if it changed how you think. Comment below. Does dark matter exist or not? The universe is waiting for your answer.